MRI machines present serious safety concerns because they generate powerful magnetic fields capable of attracting metal objects. This can result in severe injuries and equipment damage. When MRI machines are replaced with newer models, it is important to decommission them properly. This ensures the safety of patients and workers. The decommissioning process involves several key steps. Firstly, disconnecting the power supply is essential. This prevents any accidental activation of the machine. Secondly, removing the magnetic field is necessary. The superconducting magnets must be discharged to eliminate any residual magnetic field. Thirdly, the safe disposal of magnets is vital. Superconducting magnets contain hazardous materials and must be disposed of according to environmental regulations. Reusing MRI machines is possible but must be approached with caution and under the strict supervision of the manufacturer. Prior to reuse, the machine requires a thorough inspection and testing to guarantee its safety and compliance with current safety standards. The involvement of vendors and state engineers in the startup of MRI machines is crucial. These experts are responsible for ensuring the machine is correctly installed and calibrated. This minimizes the risk of accidents. To maintain the safety of MRI machines, several recommendations should be followed. Firstly, it is important to establish clear safety protocols. This involves developing and enforcing strict guidelines for the operation and maintenance of MRI machines. Secondly, thorough personnel training is necessary. All personnel who may come into contact with MRI equipment should receive comprehensive training. Thirdly, regular inspection and maintenance of machines are critical. Conduct routine inspections and maintenance to identify potential hazards and prevent accidents. Fourthly, adherence to the manufacturer's guidelines is crucial. Always follow the manufacturer's instructions for decommissioning and reuse of MRI machines. It's important to consult with experts if any complex questions or concerns arise. Seek guidance from qualified engineers and safety professionals. By following these recommendations, healthcare facilities can ensure that MRI machines are used safely and effectively. This minimizes the risk of accidents and protects both patients and workers. The magnetic field generated by an MRI machine is always present, even when the machine is not actively scanning a patient. This is because the superconducting magnets are kept at extremely low temperatures, typically using liquid helium to maintain their superconductivity. The magnetic field strength is measured in Tesla. Clinical MRI scanners typically operate at field strengths of 1.5 Tesla or 3 Tesla, which are thousands of times stronger than the Earth's magnetic field. Because of the constant magnetic field, any ferromagnetic object brought into the MRI suite can become a projectile. This includes items such as wheelchairs, oxygen tanks, tools, and even small objects like pens and paper clips. These objects can be pulled towards the magnet with tremendous force, posing a serious risk of injury or death to anyone in their path. To prevent accidents, strict safety protocols must be followed. All personnel entering the MRI suite must be screened for ferromagnetic implants or objects. This includes pacemakers, defibrillators, aneurysm clips, and metallic foreign bodies. Patients must remove all jewelry, watches, and other metallic items before entering the scan room. The MRI suite should be clearly marked with warning signs, and access should be restricted to authorized personnel only. In addition to the projectile risk, MRI machines can also pose other safety hazards. The rapid switching of magnetic fields during scanning can induce electrical currents in conductive materials, including the human body. This can lead to nerve stimulation and heating of tissues. To minimize these risks, MRI scanners are designed with safety features such as gradient coils that are shaped to reduce eddy currents. Patients are also monitored during scanning for any signs of discomfort or overheating. The liquid helium used to cool the superconducting magnets can also pose a safety hazard. If the helium were to vent rapidly into the scan room, it could displace oxygen and create an asphyxiation hazard. MRI suites are equipped with quench vents that allow the helium to be safely vented outside the building in the event of a quench. A quench is a sudden loss of superconductivity in the magnets, which can be caused by a power failure or other malfunction. When an MRI machine is decommissioned, it is important to safely remove the liquid helium and discharge the magnets. This process is typically performed by trained technicians who follow strict safety procedures. The helium can be recovered and reused, or it can be disposed of properly. The magnets can be sold for scrap metal, or they can be refurbished and reused in another MRI machine. Reusing MRI machines can be a cost-effective way to provide medical imaging services, but it is important to ensure that the machines are properly inspected and maintained. Before being reused, an MRI machine should be thoroughly tested to ensure that it meets all applicable safety standards. The machine should also be inspected for any signs of wear or damage. Any necessary repairs should be made before the machine is put back into service. It is also important to ensure that the personnel who will be operating the reused MRI machine are properly trained. They should be familiar with the machine's safety features and operating procedures. Regular maintenance should be performed in the reused MRI machine to ensure that it continues to operate safely and effectively. This includes checking the magnets, coils, and other components for any signs of wear or damage. It is also important to keep the machine clean and free of debris. By following these safety precautions, healthcare facilities can minimize the risks associated with MRI machines and ensure that patients and personnel are protected. The potential for accidents and injuries underscores the need for rigorous safety protocols and ongoing training. Remember that MRI safety is a shared responsibility involving manufacturers, healthcare providers, and personnel. When replacing an MRI machine, the decommissioning process is crucial and consists of several phases. Firstly, cooling down the magnet is essential. The superconducting magnet needs to be brought to room temperature in a controlled manner. This can take several days or weeks. Secondly, helium recovery is necessary. The liquid helium used to cool the magnet is carefully extracted and either recycled or properly disposed of. Thirdly, the removal of the magnet follows. The magnet, a large and heavy component, is carefully removed from the MRI system, often requiring specialized equipment and expertise. Lastly, there's site remediation. The MRI suite may require remediation to remove any residual magnetic fields or other potential hazards. When considering the reuse of MRI machines, several factors must be taken into account. Firstly, you need to consider the system age and condition. A thorough assessment of the machine's age, condition, and remaining lifespan is critical. Secondly, you need to evaluate the safety and performance standards. The reused machine must meet current safety and performance standards, often requiring upgrades or modifications. Thirdly, the cost-benefit analysis must be performed. A careful cost-benefit analysis should compare the cost of reusing an existing machine versus purchasing a new one. Fourthly, you need to consider the regulatory compliance. Compliance with all applicable regulations and guidelines is essential before reusing an MRI machine. Finally, refurbishment and upgrades are necessary. Refurbishing and upgrading the machine with the latest technology can enhance its performance and extend its lifespan. Ensuring MRI safety is an ongoing process that requires a commitment from everyone involved. From manufacturers to healthcare providers to personnel, all parties must work together to minimize the risks associated with these powerful machines. Always remember that knowledge, vigilance, and adherence to safety protocols are the keys to a safe MRI environment.